Hi all of you, today I came with another video which is related to the electronic subject, and it is helpful for engineering students and diploma students and also degree students, which is a very important concept, that is nothing but network theorems. And these are solved by according to the KVL, that is Kirchhoff's voltage law. Before we have solved one example problem related to that problem, we are solving these type of theorems, that is nothing but very important theorems. First one is superposition theorem. First of all, look at the statement. A network containing two or more energy sources. A network containing two or more energy sources. The flow of current in a circuit or voltage is algebraic sum of the currents or voltages produced by each source acting separately. The other sources are replaced by internal resistance, which it means if two voltages, here I have taken two voltages, if two voltages are combinedly producing the current in a circuit is equal to the sum of the two voltages produced current separately, is equal to the sum of the two voltages produced current separately. That is our statement. Next, coming to the proof. The given network consists of two energy sources, say E1 and E2. Three impedances, say Z1, Z2 and Z3. Two mesh currents, I1, I2. Next, coming to the KVL, which is nothing but Kirchhoff's voltage law. Here we have taken from the mesh, that is A, B, D, A. A, B, D, A mesh. E1, that is E1 minus, that is it is in which direction? It is in clockwise direction. If it is in clockwise direction, we have to take it as negative. If it is in anti-clockwise direction, we have to take it as positive. Next, E1 minus I1 Z1, I1 Z1 minus Z2. Z2 is related to this mesh and also this mesh. That's why we have taken both the currents minus Z2, because it is the clockwise direction, minus Z2 into I1 plus I2. Here why we have taken it as I1 plus I2? It is in anti-clockwise direction. It is in anti-clockwise direction. That's why we have taken it as positive. That is, our equation is E1 minus I1 Z1 minus Z2 into I1 plus I2. Let us solve this equation. E1 minus I1 Z1 minus I1 Z2 plus I2 Z2. Sorry, minus I2 Z2 is equal to 0. Next, E1 is equal to, these terms, all terms are negative. They are coming to RHS. The terms becomes positive. That is I1 into Z1 plus Z2. Here I1 we have take it as common. Z1 plus Z2, minus sign will becomes plus I2 Z2. This is the equation 1. Next, coming to the mesh 2, B, C, D, B. B, C, D, B. We have to write the equation from this side. Otherwise, we have to write the equation from this side by taking it as positive. Let us take from this side only. E2 minus I2 Z3 into minus I2 Z3 minus Z2 is related to both the mesh. That's why minus Z2 into I2 plus I1. Why we have taken it as first I2 and I1? Because we are writing the equation for this mesh. That's why we are taking I2 as first and I1 as next. That is, from the mesh BCDB, we have the equation E2 minus I2 Z2, sorry, E2 minus I2 Z3 minus Z2 into I2 plus I1. Now solve the equation. E2 minus I2 Z3 minus Z2 I2 minus I1 Z2 is equal to 0. Next, E2 is equal to in these negative signs becomes that side positive. I2 here we have taken it as common. I2 into Z2 plus Z3 plus I1 Z2 is equal to 0. This equation we have taken it as 2. Next, according to theorem procedure, first we have combinedly solved the equation. We have the E1 value and also the E2 value. Now let us prove. Going to the proof, we have to solve the circuit by taking the voltages as alone. First we have taken E1 as acting alone. E1 is acting alone and assume that the mesh current I1 dash and I2 dash, because here we have taken it as I1 I2, that's why we are taking it as I1 dash and I2 dash. From mesh 1 A, B, D, A, E1 is equal to I1 dash into Z1 plus Z2, I2 dash into Z2, I2 dash into Z2. Simply we can write, I will blind mark also, I will give the blind mark also. Here E1, first equation, see the first equation, E1 is equal to I1 dash into Z1 plus Z2 plus I2 dash Z2. This is equation 3. Because here E1 is acting, that's why no changes in the ABDA mesh. Just we have written the I1 as I1 dash, I2 as I2 dash. Next, coming to the equation, mesh 2, mesh BCDB, mesh BCDB 0 is equal to, why here 0 coming? Because here we are taking only one voltage, that's why we are taking the another voltage as 0, that is 0 is equal to, second equation same, I2 dash Z2 plus Z3 plus I1 dash Z2. See here, I1 dash Z2 plus I2 dash Z2 plus Z3. This is the equation 4. Next, B. Next, case B. In case B, we are taking E2 as acting alone and E1 as 0. That is, E2 is acting alone and assume that I1 double dash, I2 double dash are the mesh currents. Next, same equation. Here E1 is becoming 0 and E2 is working. I1 is becoming I1 double dash, I2 is becoming I2 double dash. From this equation 1 only, E1 is becoming 0. Next, I1 is becoming I1 double dash, I2 is becoming I2 double dash. E2 is acting I2 double dash Z2 plus Z3, I1 double dash Z2. I am giving it blind mark here because you can easily remember the equations. Okay, we can solve this circuit, we get the same equations also. We get the same equations. Okay, ma. Next, coming to the next step, we are adding the 3 and 5 and 4 and 6. Why we are adding 3 and 5? Why we are not adding 3 and 4? You will raise the doubt. I am solving this doubt because here we are adding the ABDA mesh voltages and we are adding the BCDB voltages separately. That's why we are adding 3 and 5 and 4 and 6. E1, because here 3. Third equation we are containing E1 in LHS and fifth equation we are containing 0 in LHS. So E1 plus 0 becomes E1. Next, coming to the RHS we are having I1 dash Z1 plus Z2 plus I2 dash Z2. I1 dash Z1 plus Z2 I2 dash Z2 plus next I2 double dash Z2 into plus I2 dash Z2. From this equation, from solving this equation, we get E1 is equal to I1 double dash plus I1 double dash into Z1 plus Z2 into I2 dash plus I2 double dash into Z2. This will become the equation 7. E2 is equal to I1 dash, because from the equation 4 and 6 we get E2, from the equation 4 we are having the LHS side is 0 and E2, and after the RHS adding we get the I1 dash Z2 plus I2 dash Z2 plus Z3, I1 double dash Z2 plus I2 double dash z2 plus z3. By subtracting the z2 terms and by taking common, z2 into I1 dash, z2 into I1 dash plus I2 double dash plus z3 into I2 double dash. By solving these equations, you get T2 is equal to I1 dash plus I1 double dash into z2 plus I2 dash plus I2 double dash into z2 plus z3. This is the equation 8. By comparing these equation with 1 and 2, here z1 plus z2, which one is the multiplicand for the z1 plus z2 in equation 1? I1. Here we are having the I1 dash plus I1 double dash, which is nothing but here I1 dash and I1 double dash, I1 dash and I1 double dash. Next, by comparing equation 2, that is z2, I2 is only there. What we have to get? I2 dash plus I2 double dash, which is nothing but here I2 dash plus I2 double dash. Hence, the theorem is proved from these equations. I1 is equal to I1 dash plus I1 double dash. I2 is equal to I2 dash plus I2 double dash. Thank you. I will come tomorrow with the next video. Like, share and subscribe my channel.